happens, okay, I don't have a marker, but is there any way I can draw on this? So, okay, so what really happens is that in physics there is a principle called the Pauli exclusion principle, which states that if two electrons are in a pair, the total spin must be 0. But you're kind of cheating. What really happens is that the both electrons have a different spin, but the other electron jumps to the next energy level to satisfy that. So that they're no longer paired. They just jump away from each other so that they don't disobey this principle.
So essentially the quantum entanglement excites the atoms.
It could excite so it could either make it so that it jumps to a triple state, or it could either just still stay as single states. But in fact, this process of whether it becomes a single state or a triple state is called intersystem crossing. And the real mastermind behind this is intersystem crossing, because intersystem crossing can be influenced by the direction of the magnetic field, and that's really what we're looking at here.
And can you also happen, if they are already on outer energy, can the atoms actually be ionized because of that?
I would think so. I would think they could be ionized, but the thing is, if you were to change the conditions such that they do become ionized, I don't think quantum entanglement holds anymore. You wouldn't really describe the two electrons as being quantum entangled then, because quantum entanglement would, in a sense, only holds when the conditions are not changed. Because then you'd be able to predict the other state of the electron by looking at just one electron alone. So, yeah.
What about some of the other? I mean, what were the other areas you looked
Yeah,
at? And so you talked a lot about.
Okay.
Do you think magnetoreception is the most likely?
Yes, that's what I would think. That's actually why I wanted to choose it. I also wanted to choose it because in my opinion, it's quite the most intuitive, or the one that involves the most common sense. So I could tell you about the other ones. So there is one theory that tries to propose that quantum coherence plays a role in photosynthesis, which explains photosynthetic efficiency. And there's another theory which basically attempts to say that our noses are spectroscopes, and that's why we can smell. It attempts to use quantum tunneling to explain why organisms can smell. And the third theory is a theory that attempts to explain that enzymes are efficient because they use quantum tunneling, which is actually quite plausible, because if you look at the normal shape and the lock and key mechanism or whatsoever, it doesn't explain why the rate of reaction reduces if you make the substrate heavier. But the kinetic isotope effect is one that uses quantum tunneling and can explain why the rate of reaction reduces if you use particles of higher mass. So that's just really kind of one of the points as to why they are saying that, enzymes use quantum tunneling. Apart from this, there's also another theory that states that, maybe quantum tunneling is involved in DNA mutations. And it's also another bizarre one that states that quantum physics is the mastermind behind your consciousness, which is basically what a physicist likes to do when he gets too excited. Yeah.
So did you find any areas where you didn't think that really there was enough evidence?
Yeah, really. I think the area which had no evidence at all, and it was just kind of like kids just saying, basic consciousness, wow. So there have been theories to try and show that consciousness is controlled by quantum physics. But I'm really against this because of the fact that, at least before all of this, you would at least have some sort of classical non-working model to consciousness, or anything else, before you try to explain a quantum model for it. We don't even have a proper model behind consciousness, and scientists are already trying to get excited over the fact that, I can use quantum physics to explain consciousness. Let's just start small first, and then we'll jump to the big part. So, yeah.
You talked about sort of Thorsten Ritz. You said that if you search his name on Google, he would come up.
No, not Thorsten Ritz. I said search for quantum biology on Google.
And then he would come up.
No, you see Robin.
European Robin.
Oh, it's European Robin.
The European Robin is the mascot of quantum biology.
Okay.
Isn't the European Robin cute?
Yeah.
Let us say European Robin.
Didn't you pass it?
Yeah.
No, it's
Also,
for those of you who are diligent, you would have noticed that actually.
Ouch.
yes.
I put it here as well. On purpose. Well, it's quite funny because I tried getting in touch with specialists in this field, and literally the only specialist I could come in touch with was a bird watcher. I got these official pictures from that bird watcher, and that's quite nice. But I emailed other specialists in the field, and I was hoping to wait for a response. but here's the presentation day, and they haven't responded to me yet. So,
The people working in the field more likely to be biologists or physicists?
well, okay, I know for a fact. Well, as per my experience, I would say that they're more physicists. Really, the definition of a quantum biologist is that a quantum biologist is a scientist who explains physics to biologists and biology to physicists. So, just trying to hide under the rug so no one would notice them. Yeah.
So sorry, my question basically was just like with Thorsten Ritz, are you familiar with any more of his works? Does he have any notable things that you could sort of look at?
Like the moon is made of cheese.
Boys wondering.
No, so he does have other works as well, but he is still working. Like as of now, his latest theory has been in quantum biology. He has other work, but that's all within physics. It's all within physics. Yeah, he himself is a physicist, not a biologist. So yeah, his latest theory is just this one, the radical paramechanism. So there's nothing else really.
Okay, I'm going to ask my standard question. 3 strengths, 3 weaknesses.
I think the
Ollie, you know this is going to come.
This is the first strength of my project. I chose a topic I loved. And because I chose the topic I loved, it made me interested in it. I didn't drop it out because I loved it. And that's what I want to, that's really what I want to suggest to everyone. Like, if you're going to choose an EPQ topic, you change it to something you like. Okay? Even if it might be really short, it will still keep you like glued to it. Yeah. And this is also another one I like. Okay, so one of the weaknesses I can tell you right now was that in the beginning, I immediately jumped to the online articles, and I saw really complex terminologies that I couldn't understand, and that was really scary. So I would really like to say that if it intimidates you, don't be scared of it. Start from the very beginning, like I did, and that's one of the strengths I would like to say, that you always plan your research like as an ordered progression. You start from the basic and you work your way to the top, like I was talking about mountain, and then you jump down. Yeah. So. What about the third strength? Did you get 3 strengths yet, or?
No, 2.
So, I think the third strength is I chose a topic which was, well, quite kind of strange, because initially when I joined the school, I was kind of uncertain whether I wanted to be a physicist or a doctor. But because I chose quantum biology, it was biological and it related to quantum physics. So, regardless of whether I wanted to choose medicine or whether I wanted to choose physics, it would help me in both of those areas for my, it would basically look good in my personal statement. So, yeah.
Okay, weaknesses? You've mentioned one. You started off too.
Another weakness. Okay. Wow. I don't know. This might sound like a bit cocky, but I kind of want to say that. My project has no weaknesses. But okay.
Okay. Lack of modesty.
Okay, but I would. Okay. Yeah, I actually have a really good strength for you. Unlike certain people, I, for one, listened to my supervisor when he told me to work on my EPQ draft during the summer. Each and every day I spent some time at least working on my EPQ during the summer, and that really helped me because I was not stressed as some other people. Yeah, so that's one of the things I followed. Yeah, that's a strength.
No, the weakness is he lost his summer holiday.
Yeah, that's a weakness. So I would think that maybe, yeah. Another weakness of my
Well, what would you do differently, Papa?
Yeah, like, so really, I wouldn't want to start with online articles, and also, I think I noticed multimedia presentations at last, and in my opinion, I think multimedia presentations are actually really, really, really helpful because they help to explain things quite easily. So I'm not sure about anyone else here, but I would advise that if you're actually going to do an EPQ, try to start with multimedia presentations of really on YouTube. There are so many talks about quantum biology online, and they are really simplified. It makes it really easy to understand, and I'm very certain it'll be the same for your topic as well. So I didn't notice this initially, so it made my life slightly harder, but yeah, that's one of the reasons I would say.
Any other comments?
Namdi.
Go on. Go on then.
If you were to continue from like any of the points you've done, what would you look into more? Like what sounds most feasible or most interesting?
Okay, so the most useful one I would say is avian magnitude reception, how birds react to magnetic fields. But another one that was really interesting was really how we smell, and it has a lot of evidence to it as well. But the reason I didn't want to include it was because it was kind of complicated compared to this. The idea is, have any of you heard of IELTS?
What?
IELTS.
IELTS.
Yeah.
As in the exam.
But it's not IELTS, it's IETS. IETS. It stands for Inelastic Electron Tunneling Spectroscopy, and that's a method that relies on quantum entanglement. Not quantum entanglement, quantum tunneling of electrons. And what scientists have done is that they propose that this mechanism occurs in smell. So one of the advantages to this is that it could explain why the thing is, this method is used to analyze Born frequencies. And when humans smell, I think you'll find that sulfurous smells like rotten eggs, they smell similar to smells of hydrogen boride. What do you call it? Well, they smell similar to that compound, and that's because they have similar Born frequencies, which is what the IETS also measures. But what was the disadvantage of it? Yes, it was that when they actually attempted to find the mechanism in the nose, they didn't find it. The idea is that if this mechanism did exist, it should have some form of electron transport, but they couldn't find this occurring within the nose. So, it has its advantages and disadvantages as well. Another interesting one, if you like, is go on. What was the question?
No, what was that other from?
Another one that was interesting is photosynthesis, which in photosynthesis, during one part in photosynthesis, the electron has to jump to the reaction center, and jumping from and for the electron to jump to the reaction center, it's actually quite hard because it's a bit of a maze. So the electron has to really choose the shortest path in order to make the process the most efficient. And we see that according to photosynthetic efficiency, the electron always takes the shortest distance. And you can only explain this using quantum physics, but you can't explain it using classical models. So classical model says that the electrons just walk around like they're drunk until they finally hit their house and they land home. But quantum physics says that the electron cuts itself into a million pieces, and when it hits the area that they wanted to go to, it says, haha, you were looking at the fakes, I was really here. You get it? So it takes multiple directions at the same time, and it kind of pranks
The one that arrives is the real one.
Yeah, the one that arrives is always the real one, and that's the one that's mind-boggling.
Wow.
Yeah.
Okay, you have a question.
No.
Oh, right.
Yes, you do have a question.
Final question. Could you explain your shirt, please?
My shirt.
I've been staring at it the whole time. I like milk. It's a monkey, right?
Yes.
Yeah.
Yeah.
Oh, you don't see the mustache.
Right.
Okay.
You might want to come in my shirt.
I have to.
Well done, Taban. That's excellent.